So finally, I am gonna close this course. So what all we have seen, I will conclude now. So we have first seen the why modulation is required and what all benefits we can get from modulation. Then we saw amplitude modulation. In that amplitude modulation, first we started with DSB-FC. We saw the modulation index, transmitted power bandwidth, modulation efficiency or power efficiency of DSB-FC, the AM signal. Then we saw the generation via square law modulator and then demodulation through square law demodulator. Then we saw demodulation, another demodulation technique, that is envelope detector, synchronous detector. Okay, so these all things we saw in the AM. Then there was another technique which was better than AM, which was DSB-SC, where mu was greater than 1 modulation index. Then there also we saw transmitted power or total power, bandwidth, modulation efficiency, then generation via balance modulator, generation via ring modulator, demodulation via synchronous detector. We all saw this. Then SSB-SC we saw, which was better than DSB. There we saw transmitted power, bandwidth and modulation efficiency, the generation via filter method, demodulation via synchronous detector. Okay, there are other methods as well, but I have covered only one or two just to get the feel of the generation, okay, or demodulation. Rest you will understand. There are other techniques as well, but I don't want to fall for that. I just want to cover intuitive feeling of this course. Then we saw VSB also to transmit certain types of signals. Okay, then we saw how it is SSB, like it's like SSB only. We saw the filter VSB filter, so how it is slightly different than SSB, but it is more like SSB only. So we saw in amplitude modulation these all schemes. Now we will see what all things we saw in an angle modulation. Then we covered angle modulation, where we saw FM first, the modulation index, the Carson's rule, power efficiency, the frequency deviation. These all things we saw. We rigorously saw frequency modulated signals. Okay, there we saw the generation of WBFM, NBFM through direct indirect methods, how we detect through PLL we have seen. Similarly, we saw in phase modulated signal the beta for PM, then Carson's rules for PM, how we can generate PM signal via FM, and how you can demodulate PLL through PLL PM signal as well. There are certain advantages and disadvantages also we saw for FM, PM and the AM techniques. So it depends upon the requirement whether you have to modulate through angle or through amplitude. We saw all this. And then we saw mixers and the use of mixers in AM receivers. Basically we saw tuned radio frequency receivers and super heterodyne receivers, how you used mixers and all. We saw IIR, image rejection ratio, and the characteristics of AM receivers like fidelity, selectivity, then quality factor, everything we saw here in AM receivers. Then we moved on to the most important part, was the noise analysis, how noise affects these signals. We saw the figure of merits for DSB and SSB was 1. For AM it was K square P divided by 1 plus K square P, where P was message signal, K is amplitude sensitivity. Then we saw for FM it was 3kf square P divided by W square, where W is message frequency, kf is frequency sensitivity, P is the power of the message signal. Okay, then we saw for PM it is kp square P. Okay, so we saw all these things, and we saw rigorously. I tried to include more problems also in this course. Okay, so previously one of the students in information theory course told me that you don't include problems, so I included enough problems in this course. So I hope you enjoyed the course, and I'll see you guys in next course. Okay, so these are all things we basically covered. in this course.